Şimdi bir teorem daha yazacağız. So I'll write down another theorem for Fourier about Fourier series, but this time we will not assume that f is not like this. So we will assume something less on f. But first, I need to define something. Okay, so we have a definition. Let f minus L to R be such that f of L is f of minus L is f of L. Then the periodic extension of f of x is the unique periodic function f tilde of x of period 2L such that f of tilde f tilde x is equal to f of x for x between minus L and L. Yani şöyle yani demin yaptığımız şey diyoruz. So if you have a function defined only on this interval, let's say, it's a function like this, but at the end points, it has the same value. So let's say it starts from this point and it is any function, okay? And ends at the same point, same value. So f of minus L is equal to f of L. Then the periodic extension is just the function we saw last hour. You copy this and then paste, okay? So you take this and paste it here, so you get this thing. So this is 3L, değil mi? So this has length 2L, 3L, and then you do the same thing here. So minus 3L. So it is like this. And so on, okay? So you just copy this function and then paste 2 units left, 2 units right, and so on, till minus infinity. F tilde var. Burada da var işte tilde. Yani şu. F is only this one. F is only this one. Okay. This is F. And the whole function is F tilde. Extension'ı F tilde. Tamam. Efendim? Evet. Kendisi F. Extension'ı F tilde. F is defined on the closed interval. This interval. F tilde is defined on the whole real line. Periodic extension. And the theorem will be the following. We have seen, this strong theorem, which tells us when the series is convergent, right? If f is twice differentiable and so on, then the series is convergent. But in general, uh, it is not. So we have this theorem. This is pointwise convergence of Fourier series of Fs. So let this time f of x be a C1 function. So it is continuously differentiable, but not necessarily twice differentiable. And assume that assume that uh, at the end points uh, it is equal the values at the end points and the uh, derivatives at the end points are equal. Okay, then uh, the Fourier series, then f of x is equal to its Fourier series. Yani hala birbirine eşit bunlar. Fourier serisine eşit. Ee, bir dakika aa, o nerede? Yani bu şey söylüyor. So under this weaker condition also f of x is equal to its Fourier series. Uh, and if f is piecewise differentiable, so that's another theorem. Let f minus L to L to R be a piecewise differentiable uh, C1 function. Piecewise C1 piecewise differentiable function demek. Bu kötü bir şey oldu. Okay, let me write it this way. I'm sorry. Be a piecewise C1 function and uh, let f bar be the bunun ne olduğunu söyleyeceğim. Adjusted function as defined below. Şu fonksiyon, adjusted fonksiyon dediğimiz şey şu. Ee, Bildiğim şu olması lazım bunun. Şu fonksiyon şey fx'e eşit if f is continuous at x, e, 1 bölü 2 fx plus fx minus, ya aslında bu aynı şeye denk geliyor da neyse. Aa, şöyle yazayım. Aslında şunu sileyim, şöyle yazayım. Gerek yok ona. Şöyle yazayım. Açıklayacağım bunu. 1 bölü 2 tane f x plus f x minus, ee, 10, şöyle, şeyde de uç noktalarda da şimdi şunları açıklayayım ne olduğunu. So let me explain what are they. Statement yazayım olmazsa da ondan sonra onları açıklayayım. Then the Fourier series of f of x is f bar x. Uh, okay. Evet, bence bu kadarını bilseniz yeterli. Şimdi şu terimlerden ne kastediyoruz onu açıklayayım. So let me explain now what are these terms. So, okay, suppose our function is something like this. Okay. Şurada da şöyle olsun şu. So here this function is piecewise C1. It is continuously differentiable on some intervals, but there are some points where the function may not be even continuous at those points. So at this point, for example, it's not continuous. What is f plus and f minus? Suppose this is the point x, okay? F x plus is the following. This is just the left limit at x. So as okay, ya da şöyle diyeyim, a diyeyim buna. A noktası a plus as x goes to a from right, f a minus limit as x goes to a from uh, left. Yani biri sağ limit, biri sol limit. So this point, uh, okay, for this one, if it is continuous, of course, at this point, then the left and right limits are the same. But in general, they may not be the same. So if f is continuous at A, then of course this F bar A is what? It is the arithmetic bir dakika. Bu absolute value değil tabii ki bunlar ya. Bunu şöyle yanlış yazmayayım. Bu şey parantez. Aritmetik ortalaması. So, what is this? This is just uh, left limit. So 1 over 2 left limit at A plus, sorry, right limit plus left limit at A. But if f is continuous, then both limits are equal to f of A. So this is f of A. This is also f of A. So this is f of A. Therefore, this adjusted function is equal to the original function at the points where f is continuous. So hence, f bar is equal to f at the points where f is continuous. And at the points where it is not continuous, what is that? So if these are not the same, then the value of this function is just the arithmetic mean of the left and right limits. Yani fonksiyon eğer bir noktada sürekli değilse, so if function is not continuous at, let's say, this point, so this is, let's say, at the point A, it is not continuous. Left limit and right limit are not the same. Our adjusted function takes the arithmetic mean of this two values. So this is fa plus, no, minus. This is fa plus, and this is the arithmetic mean of these numbers. And the theorem tells us that our Fourier series of f converges not to f but this f bar adjusted function, right? So this theorem tells us that our function has Fourier series and the Fourier series of f converges to not f but f bar. Tamam mı? Yani fonksiyonun eğer continuous değilse bazı noktalarda, so if your function is not continuous at some points, when you take its Fourier series, the function you obtained is not f but it's adjusted f. Tamam mı? And at the end points, again, at the end points, this f bar is just the arithmetic mean of the end points. Okay? Yani her iki uç noktadaki değeri bu ikisinin aritmetik ortalaması gene. Evet. So this is the theorem. So it's a bit complicated, you know, the relation between f and its Fourier series. If you know this much, then it is fine. Okay. Peki. Hı, şöyle yapalım. Şunu sileyim. Kaldırayım. Fourier cosine and sine series. Okay, now let f of x be a function defined on 0 to L. Okay, so it is not from minus L to L, but 0 to L. Okay, then we can extend f to minus L to L as an odd or an even function in a unique way. How? Odd extension. Kim ona ne isim veriyoruz? FO diyoruz. Minus L to L. Sıfırdan L'ye kadar I know what the function is from 0 to L. So I have to tell you what the values between uh, on the interval minus L to 0. So on okay. So it is equal to f of x if x is between 0 and L, and it is just uh, minus uh, minus x if x is between minus L and 0. Yani ne yapıyorum? Eksi L ile 0 arasında bu fonksiyonu tanımlamak için onun eksilisini alıyorum. Dolayısıyla bu pozitif bir sayı oluyor. F'de onun değerini buluyorum. Sonra bir önüne bir eksi daha koyuyorum. So if you define it this way, then you get an odd function. This is what you do. Your function is given here. Okay, so it's an function defined only here. Okay, let's say this function. What you do on this side of the x-axis, you define it this way. Okay, at any point x here, you look at minus x, and then you compute f of minus x, and you take its negative. So this is minus f of minus x. And this way you get an odd function, okay? So this f0 on this interval is an odd function called the odd extension of f. F'in odd extensionı. Sıfırda evet sıkıntılı. Orada kim? Yazar da pek ona aldırış etmemiş. Yani bir noktanın çok bir önemi yok. Yani en kötü şöyle yapabilirsiniz. Çok dert ederseniz şunu şöyle yapın. Bunu da sıfır diye tarif edin. Tamam mı? Sonuçta hep integral falan aldığımız için tek bir noktadaki değerinin bir önemi yok. What about even extension? Efendim? Gerekiyor tabii ki. Onu size bırakıyorum. Evet. Okay. Even extension f e minus L to L to L. So this will be defined how? F e of x. So it is f of x if x is between 0 and L and between minus L and 0. It is just belki öyle mi yapmak lazım ama yok bu yazar hiç ona aldırış etmemiş. Biz de öyle yapalım. İsterseniz hani şöyle yapın. Ne bileyim. Efendim? Ha, evet bunda sıkıntı yok zaten. Evet evet tamam. So what is this function? Our function has, let's say, graph like this. F, we extend this to minus L to 0. And we just take the same values. So we just, take the mirror image of this. So we get this. Şimdi şöyle. So it is symmetric with respect to the y-axis. Okay. F of E from minus L to L to R is an even function called the even extension of f of x. Peki niye bu önemli? I mean, why even extensions and odd extensions are important? It is because of the following. Let me explain it here. Well, sometimes we will need sine series of a function. Sometimes we will need cosine series. So we have a option. We may represent a function in terms of sines only or in terms of cosines only. Uh, how? Well, suppose we are given this function from 0 to L. This, for example, could be heat distribution on a metal bar like this. Suppose we have a metal bar of length L and at any x, let's say f of x is the temperature at this point. Okay? And we are asked to solve the heat equation. Okay? Uxx is equal to ut, something like this. Okay, this is heat equation. Uh, it is advantageous to represent f in a series consisting of sines sometimes, cosines sometimes, and this approach gives us that option. How? I can just extend this function as an odd function to minus L to L, or as an even function minus L to L on the, so 0 L minus L on this part, they're both F. On this part, they are not F, of course, but so that this function is even or odd, depending on which one you choose. But on this part, actually, on the interval you are interested in, on the, this object, both of them are equal to f of x. Yani problemi böyle imajiner bir şekilde şey yapıyoruz, extend ediyorum. Diyorum ki bu metalin, so we assume that this metal bar has length 2L starting from minus L to L, and my temperature distribution is given like this. I may use either this one or this one. It's up to me. Okay. But here it is F. Okay. And then I can use this function and obtain a Fourier series for this. So Fourier series of F0 will be what? It's an odd function. Therefore, Fourier coefficients an will be what? 1 over L okay, minus L to L f0x cosine n pi x over L dx, right? Well, since it's an odd function, this is odd, this is even, the product is odd, therefore this is 0. So all the an's will be 0, therefore you will have only bn's. So you have Fourier series of this will be just like this, sine n pi x over L. And we know that, this expression is equal to not maybe f, but adjusted f. Okay, on the whole interval minus L to L, but on 0 to L, it is just f of x, değil mi? Yani bu nerede birbirine eşit? Bunlar birbirine eşit on minus L to L, but on 0L, this is just f. Or I can use the even extension. If this was even, this time let me compute bn. So I have sine here. So this time this is odd. Product is odd, and this is 0. Therefore, I will have only a0 over 2 plus an cosine n pi x over L. Okay. A0 da 0 çünkü. Tamam mı? A0 da kosinüs gibi davranıyor ya. So this time I will have my function written in terms of cosines only. Şimdi bu fonksiyon eksi l'den l'ye kadar tanımlı ikisi, ama sıfırdan l'ye her ikisi de f. Yani dolayısıyla f of x is equal to both this series and this series on 0 to L. Right? On 0 to L, this is equal to this one, and this one. And so on this interval 0 to L, actually on the interval I am interested in, I can write my function in a series we have in which we have only sine terms, or in a series like this, which we have only cosine terms. Fizikte aslında böyle şeyler hani yapılır ya, bir charge var. İşte şuraya bir olmayan bir charge koyuyorsunuz. Hani burada eksi işte şu kadarlık charge olsaydı ne olurdu falan gibi. Ona göre problem çözüyorsunuz. Burada da öyle. Yani bu metalin uzunluğu L kadar. So this I have this metal bar here. There is no bar here, but we just imagine as if we have another metal bar here, and so on. Okay. So what is the conclusion? Let me just write down the conclusion. So any function, I mean, not any, integrable and so on, function f on 0 to L has a Fourier sine series and a Fourier cosine series. Bunları da şöyle yazalım. Yani bizim f'imiz f of x hem şeye eşit, bir a0 bölü 2 artı, yani şöyle diyeyim, f even x, evet şöyle diyeyim, even olursa şuna eşit an cosine n pi x over L. Burada an neydi? Remember, an is this 1 over L times minus L to L f even x cosine n pi x over L dx. Here, this is even, this is even, so the product is even. Therefore, this is just 2 over L, 0 to L, f even x cosine n pi x over L dx. But on the interval 0 to L, f of x is the same as f of x. Therefore, this an is just 1 over L times 0 to L f of x cosine n pi x over L dx. Yani f'i bu şekilde yazabilirim. Tabii ki we can also write odd function, and this time I will have n from 1 to infinity, bn sine n pi x over L. But this time bn will be what? Bn will be just the same thing. Okay, I will have something similar. Bn will be f odd times sine n pi x over L. This is odd, product is even, and so on. So we will have just 1 over L times 0 to L f of x sine n pi x over L dx. Efendim? Şurada şurası 2 bölü L olacak. Evet. So these are both 2 over L's. Sorry. Yok, odd extension. Ama odd extension'ı kullanırsam f'i şimdi bu f even ama 0 L'de bu f ile aynı şey, right? This is the same thing f of x if x is between 0 and L. And this is also f of x between 0 and L. So f of x can be written like this or like this. It is up to you. Okay? Yani şöyle söyleyeyim. F of x'i iki türlü de kullanabilirim. Daha doğrusu ifade edebilirim. Bir sinüs serisi veya kosinüs serisi olarak. Siz nasıl istiyorsanız. Son bir satır yazayım, bırakacağım. So, f of x is equal to this. Okay. A0 over 2 plus a of a n cosine n pi x over L for x between 0 and L, and f of x is equal to n from 1 to infinity bn sine n pi x over L on this. So same function on this interval can be written in a two different ways. This is the cosine series, cosine Fourier series of f. This is sine Fourier series of, ya da Fourier sine series, Fourier cosine series. And depending on our problem, we may need sometimes this one, sometimes this one. Okay? Yes. Efendim? Yani eksi ile sıfır arasında verilseydi. Tamam. Tamam, işte o zaman even, so if you want to extend, so you are given a function like this, you want to extend this as an even function, so you can just do this, take its symmetry. Odd function, or as an odd function you may extend it like this. So uh this is f, this is f even, this is f, this is, the whole thing is f odd. Oldu mu? Tamam. Yani biraz bu şeye benziyor aslında. Hani this is like, you write a function as a polynomial uh, uh, series, or power series, where you have only even powers and where you have only odd powers. Something like that. Yani işte onun gibi bir şey. Efendim? Bununla ilgili soru değil de şunu kapatayım da. So,